In 2001, a radio telescope detected a short and very strange signal. There are reasons to believe that this signal was produced billions of years ago in a distant galaxy in a very energetic and catastrophic event. Since that discovery, there have been several similar signals recorded. If these signals are indeed extragalactic, they could provide us invaluable information about the content of the universe. This video is about fast radio bursts. About this signal, we don't know what causes it, we don't know where they come from, nor do we know when they happened.
No, stop, cut. How am I supposed to make a documentary about these bursty thingies if you don't know what you're talking about?
All observations of FRBs so far have been made by radio telescopes, which actually don't look like conventional telescopes at all, but rather like TV parabolic antennas. And that's, in fact, what they are. In order to observe waves from very distant objects, we need very big antennas, like the 64-meter Parkes Observatory.
The first FRB was recorded here at Parkes in 2001.
Then, in May 2014, for the first time, another FRB was detected in real time.
Right after the detection, we contacted 12 different telescopes around the world to make them look at the same part of the sky as Parkes. Unfortunately, none of them found anything. It was too late.
Next time, we will be prepared to act more quickly. Imagine a wave that was emitted from a distant galaxy. This looks like a wave with a fixed frequency, but in reality, the light coming from the sun, or a light bulb, or a firefly, is usually the sum of many waves of different frequencies. As the waves move through space, every now and then they interact with some particles like electrons. The waves of lower frequency are more affected. They get delayed and arrive on Earth slightly later than the waves of higher frequency. This effect is called dispersion. This is what the signal of an FRB looks like. On the vertical axis, we show frequencies, and on the horizontal axis, the time when the wave arrived. We see that the waves at lower frequencies arrived later than those at higher frequencies. The hypothesis is that this delay is caused by dispersion. But a signal will not be dispersed so much by traveling from within our galaxy. The FRB must have traveled from much further away.
In order for us to be able to see something that far away, it must be incredibly energetic.
What could have produced such an extreme event? We need to detect more of them to test the theories. Using the 1-mile-long Malongolo telescope, we should be able to observe FRBs much more frequently. The observation of numerous FRBs will not only provide interesting information about the astrophysics of their sources, they can also teach us about the contents of the universe, its dark matter and dark energy, two of the biggest puzzles in modern science.
Bravo, that was all very nice, but I have heard that at a certain time you detected a signal which looked like an FRB, but turned out to be something much less interesting.
A peryton is something that looks almost exactly like an FRB. However, there are a few subtle differences.
FRBs have been detected around the clock. On the other hand, perytons tended to be observed during the day, particularly around lunchtime, so we thought, what could be causing them?
We went around Parkes and used all existing microwave ovens. We found out that when opening the door of the oven before it turned off, perytons were produced.
So, the peryton mystery was solved.
The news went all around the world. Unfortunately, many articles were misleading. They claimed that FRBs turned out to be microwave ovens, which is certainly not the conclusion of the study. It was the perytons that were produced in a kitchen, not FRBs.
We will find a solution to the FRB enigma.